And this time, something about RAGOps. Who knows what RAGOps is? Raise your hand. That's it. I've stolen one question from him. Stage is yours, sir. Enjoy.
Thank you. All right, hello guys. So today we are going to talk about RAGOps, but not just your typical RAGOps. We are going to go from basic to advanced. But first, I need to understand how many of you have actually tried to play with an LLM, either locally or through an API? Okay, you guys have the idea of it. How many of you know what agents are? How many of you have built a RAG application and shared with your colleagues? How many of you hate yourselves when you share it and your colleagues find bugs? All right, so let me take you to the next level. So today we're going to talk about what is RAG. We're going to go through document processing, prompt engineering, retrieval, monitoring and evaluation, and I'll give you a demo in production. All right, so first, who am I? My name is Prince, and don't worry, my family is not royalty yet. And I'm an MLOps engineer and founder at Kulissiwa, and these are some of the projects that I've contributed over the years. This is all on GitHub, so if you check me on GitHub, you will see all those contributions. And if you are part of these communities, hi. All right, so over the years, I've been building machine learning applications. I started back in 2017. I was super excited after Google announced TensorFlow, and I just couldn't stop myself from building stuff. So first project I tried to build was a style transfer SaaS that actually made some money in India, around 10,000 rupees, something like 250 zlotys. That's a lot of money there, don't laugh. And then I went on to build a speech copilot. I like to give speeches, and I was like, what if I could actually make the script using a large language model? Back then was GPT-2, so I fine-tuned it, and I deployed it to production. I fine-tuned it on the 100 best speeches of the world. There's a book with the top 100 speeches, and I kind of deployed it. That was like my first experiment with it. And then later on, whilst working at Neptune AI, I developed the documentation bot to help our support team be able to handle all of our hundreds of customers. And nowadays, I'm working on Kulissiwa. And I'll talk about Kulissiwa in a minute. All right, so let's go from rags to riches. Today, you are going to get out of here knowing what to do and why you're doing it. So we are working with foundation models. So we first need to understand how they're created and how they work. So nowadays we know of ChatGPT, which is mostly a text, and if you use the application, you have now vision, which we call those are modalities, and when the model can do both text and image and more types of data, we call them multimodals. So models, that's a mouthful. So we have our pre-training stage where we just teach the model how to predict the next word, how to complete a sentence, and so on. Then we take that model and we do what we call domain adaptation. You know about domain adaptation, but from a different name. You most likely know about fine-tuning. It's kind of the holy grail of deep learning. But we also have prompt engineering with foundation models and retrieval. So in this talk, I'm going to kind of skip fine-tuning because it's expensive. Not everyone has hundreds of thousands of dollars to do fine-tuning. Not that every type of fine-tuning is expensive, but most of it still is. All right, so what is retrieval? How many of you know what retrieval stands for, RAG stands for? So please, there, white shirt.
Okay, sure. It's retrieval-augmented generation.
As the name suggests. Absolutely. So retrieval-augmented generation helps models like ChatGPT or GPT 3.5 Turbo or 4 stop saying, as an LLM, I don't know, I was trained till 2021 or 2022. So basically what retrieval-augmented generation is an architectural approach to help the model increase the efficiency by providing custom data. This could be your private data, your documents, images, and so on. So you pass that as context to the model in the input. So context is just the input. And the model, you either ask a question or you have a task for it to complete, and the model is going to use that external information to provide you with an answer or a particular action. And this helps mitigate first hallucination. You can also provide it access to, like I said, proprietary data. It provides you also with source attribution. So you can now know what the model is using to generate the answer. That is important because you want to be able to verify and understand whether the model truly is performing well or not. And it's also domain versatile. So you don't have to do fine tuning to be able to use these models to tackle different tasks in different domains, right? So for example, if you're in the medical field and if you are in the law field, you can still use the same model. Of course, with time, fine tuning can help improve the accuracy. But from the start, if you don't have enough data, you can just get started with retrieval augmented generation. All right, so what is the ops part in RAG? Most of you, if you come from the software background, you know that the famous saying, it works in dev or it works in my laptop. That's not my problem. But in this case, we want to be able to integrate the systems with other interfaces. For example, if you have a web application, you have an API, you want to be able to connect that and be able to have a consistent performance. On top of that, I've seen some use cases where people are connecting this to some automations. For example, generating a report that answers a particular question every week. So for example, if you're in the finance industry, you might ask, what is the performance of a particular index, monthly or whatever frequency? That's one of the ways you can do that. Another way is data management. So you will be responsible for handling the data syncing, processing, and the retrieval as well. And finally, you'll be able to monitor your model so you can consistently update it when it's necessary. And we'll see some use cases about that. So now, when you're building a RAG application, there are 3 things that you can think about when you're getting started. First is data. Do you have the data? That's the first question you should ask. Of course, it's not, in some cases, it's not truly relevant because these models are versatile, like we explained before. But if you do have the data, your way of approaching this problem is a bit different. You can gain some performance by having the data. Second is there a baseline? So do you have a benchmark as to what good looks like? Do you have a metric that you can look at and say, okay, if we achieve this metric, this model is performing well, or this RAG pipeline is working well? Then latency. So I've seen some competitors and even people in the space that go towards streaming. But if you really think about it, not every use case requires streaming. If you're doing a report that is like a scheduled job, you don't need streaming. You don't need to make it immediate. You can create a different type of pipeline, a different type of application, and perhaps even save resources. All right, so at the high level, this is what a RAG pipeline looks like. You have your data. It could be public or private domain. It comes in multiple formats, either structured or unstructured. So structured, you can think about it as tables or any information that's in a formatted way like JSON. And then you have unstructured, like images. So we talked about multimodal. RAG can also be multimodal. And the first step you go through is kind of processing that the data. And a common use case would be text splitting. If you have a document with 100 pages, you split that document into different pages, then it could be, that's one strategy. You can split it into pages, split it into smaller sentences. Then you create an embedding. So an embedding, all it is just an array of numbers that can represent data information, that text, in the latent space. That's just the way people in machine learning make things complicated. Just imagine that it's the representation of text. That's it. Then after that, after you have your vectors, you create a kind of vector database, right? Or you use a vector database. But all it is just a table with your content, your chunk, your embedding, and some metadata. Why is metadata important? So imagine you're serving an application with multiple different users, and each user has their data, and you want to keep it private. You might want to use metadata to be able to filter the data so that users don't see each other's data. So that's why it's optional. In some use cases, if your company doesn't have any kind of access policies, you don't need metadata per se. You can just use all the data that's available to you. After that, you just save it to the vector database, and you also pass in your retriever here, your embedding. So what this is, when you see here the retriever is just a wrapper code that takes your embedding, takes your vector database, and whenever there's a user input, a question or a task, it embeds the query, creates this vector, and it tries to find similar vectors using math. And after that, you get some documents, some chunks, and you pass that to the LLM, and the LLM is going to generate a response. So this is just a high-level overview of it. Any questions? Okay.
A question about documents, parsing documents, and
Yes.
images within the documents.
Yes.
Of course, this is tuned to text indexation, right? But
Yeah.
have you had success with like processing charts or images?
That's a great question, and I actually have a slide talking about it. Okay. Now, I created this slide and I wrote the taxonomy of RAG pipelines, but it's just basically some of the RAG pipelines I've seen in the wild. And if any of you follow me on LinkedIn or Twitter, I post a lot about these graphs. Pretty much these graphs just represent the RAG pipelines. And here you will see from the most basic one to the most advanced. So let's go. First is vector search. This is kind of the naive approach. Everyone, when they heard about RAG, was like, okay, let's just embed the data, and then we can do some similarity search, and we can create an answer. It works well for majority of use cases. But what are some of the main issues with this approach? Can anyone tell me? Anyone? Sure.
Sometimes you don't have data in this database.
Okay, that's one. Any other?
There is no context of the conversation.
Not really. You are retrieving similar information, so you would still get that information. But what are some of the pitfalls with this simple approach of just finding similar text?
You will find too much text.
That's one.
Document,
Excuse me?
the same document.
The same.
There's no enough diversity among other documents. So for example, if you are searching for one person,
Mhm.
you will have the same thing paraphrased, like who Albert Einstein was, like in 10 different ways of saying.
That's a good one.
If you don't have sometimes you get a cat, sometimes you get a dog.
Mm-hmm. That's a good one. All of you guys are pretty good at this. So let's see. So first is limited keyword search. As some of you mentioned, you might not be able to find the particular keyword, or you might be able to find a lot of the keywords, but not really the context that's relevant to the information. This can happen for a lot of reasons. In my case, for example, when I revamped the pipeline for Kulissiwa, I noticed that I had really large chunks, for example, for PDFs. I was embedding an entire page, and I noticed that there was this particular question. The answer is there. I know where the answer is because I read the document, but the answer is in the middle, and there's no way you can find similarity because the answer is in the middle of the sentence. So the one way to do it, to approach this, is by finding a way to not have large chunks. And I will talk about that. Another is multi-turn conversations. So because you are just retrieving similar information, you have the case where the user will say, hi, and the LLM will answer, hi, how are you? And you will say, I'm good, my name is so. And then it would ask again, what is my name? But the LLM already forgot because you're only processing the last query. So, and I'll focus on this in just a bit. And then bad retrieval. So this is the case where your context or the information you feed the LLM is all wrong. Excuse me. And you expect the LLM to return a relevant answer. So how do you address these? One way is to use hybrid search. So what hybrid search is you have your embedding model, your normal dense embedding model, OpenAI, text ADA, or text embedding 3, and so on. But then you have another type of model, it's called BMI 25. It creates sparse embeddings where you can actually embed certain keywords. So for example, if you're looking for the keyword doctor in your queries, the model the retriever will be able to find those chunks much easier if it has a hybrid search mechanism. But this doesn't necessarily address all of these problems. It addresses number one. But you still have 3 others. How do you guys think we can address the remainder? Any ideas?
Agent.
Excuse me?
Agent-based approach.
Agents, okay. A big knife, actually a sword, to have dinner. But it's a good one. It's been used. Any other ideas?
When we are splitting our information into documents, we can make these documents overlap so that we don't miss any information that is in the middle of the document.
Okay, I see. Some techniques, some naive techniques need overlapping. That's a good one. Any other?
So we have, for example, small chunks for the embedding and for search, and then retrieve more context for the answer, right?
Good one. That's a good one.
Smaller is better to search.
Uh-huh.
Chunks, right? Smaller chunks. So
Uh-huh.
like documents called smaller chunks.
Wow, you guys are good. Okay, so let's talk about contextual compression. So there was a paper by Microsoft, and I tweeted about this. I think it went viral, this tweet, but if I remember correctly. So the idea is very simple. You have your vector database, you retrieve your documents, but then before you pass on the documents back to the LLM, you either do one of 2 things or both. The first one, you pass it on to another LLM or the same LLM with a different prompt where you're asking the LLM to eliminate all the documents that are not relevant to the question. That's one way. Another way is to use embedding filtering. So you'll say if the embedding of the query and the embedding of the document is not as high, you drop those documents. Or you can do both. In the paper, they kind of do both, and it works really well. And I'm actually using this as well. Then we have retrieve, rewrite, and read. This is, I guess, another paper from Microsoft, if I'm not mistaken. But it's another paper. The idea is very, very interesting. And it was one of the first ideas that I explored when I was building Kulissiwa, which is for whatever query I get from the user, I pass it on to the LLM, and I ask the LLM to rewrite that query. Why is this? Have you ever noticed when you go to Google, your first question is not really good? You're like, I wanted something that's similar to this, but it's not really this. And you kind of go through many cycles until you get the right query to answer it. LLMs are very, very good at understanding intent. So they can kind of get the idea of what you're trying to do and say, okay, this person most likely wanted to do this, but of course it's not gonna say it that way. It's just gonna rewrite the query. But why just do that to one query? Why not create multiple queries? You create 3 variations of the same question. Then what happens when you go to retrieve? Instead of retrieving only these 2 documents here that are closer in the vector space to the user query, you can get way more context from the vector database or the retriever just by rewriting the query in different ways. And this can improve your accuracy significantly.
But then do you evaluate relevance as well at this stage? Like there
Yep.
are two different techniques.
We are going to get there.
Now you get many.
Indeed, you do have way more documents than before, and that can also cause certain problems like context size. If your LLM, for example, only has 4,000 tokens and this is bigger, your application might break. There are drawbacks to this, but it is super powerful.
And I have also a question for previous slide. If you can switch back.
Okay.
And in that bottom line, as I understand, there need to be some threshold
Yes.
under which we need to drop that.
Exactly.
those,
It's just a simple if.
Yes. So, is there some methodics how to find that threshold?
For me, for example, in my case, I iterated between 8 and 0.8 and 0.75, and 0.75 was good enough that it wouldn't drop certain like the extra questions, extra context. 0.8 is fairly high. You have to have really good embeddings for that. So for me, 0.75 worked pretty well.
So it will work for like different applications. That same threshold.
No, you'd have to iterate and test for your own application.
Okay. Thanks.
Okay, so you might ask, Prince, why rewrite queries? And actually, I got this question from a friend of mine, dear Hindi hacker and customer. He asked, okay, could you explain why would you rewrite the query history if it exists? And how does the query rewriter work? So, like I explained earlier, imagine this is your conversation. You have your history. You said, hi, how are you? You went through the conversation. And then normally you wouldn't, when talking to someone, you wouldn't start the presentation, like I wouldn't start the presentation from the beginning to go on to the next point, right? So the user would ask like, why is that? But what is that, right? The LLM does not know this. So if you pass on the history and the query, the LLM can now rewrite and say, why is X important, or why X and B behave in a certain way, for example. And this is gonna give you way better performance than you just taking this query, why is that, and passing on to your vector search. Like this will not work. Why is that what? So you will get this that is another context that not even relevant to what the user is asking. Okay, so someone asked about retrieval scores and relevancy. So this is where you can use re-ranking. Cohere, I have a friend that works there, Cohere, great company. They have a really great API for a re-ranker, and it's pretty fast. I tried it myself. So my customer asked, okay, should I use a re-ranker, yes or no? And my answer was, well, it depends, because they can be slow, but actually these guys are pretty fast. And at the same time, I had a lot of questions myself about this because I don't use it. So I said, okay, let me research about this and understand it better, how it works and how it would be better. Here's one use case where the user query is gonna be sent to the vector database. You're gonna get your documents, and here you can increase the number of documents that are returned. You can have like 10, which would give you a bigger surface area to work with. Then you pass it on to the re-ranker with the query. The re-ranker is basically an LLM that's gonna take the query, is gonna check the documents and give the relevancy score to each document. And then you can use that relevancy score to filter out some of the documents so that only the top relevant documents are returned. This way, if the user asks a question, it doesn't get 10 sources, it only gets like 2 or 1 source that is relevant to the answer. Okay, yes.
Just a quick question. You said that you are using LLM for re-ranking, or this Cohere is using LLM for re-ranking. But is it kind of heavy or too heavy? Like there are some models for ranking from what I know. I don't know if you use any of them.
Yeah, well, it's a custom LLM that they fine-tuned particular for this. And I don't know the architecture of this LLM, but I believe it most likely doesn't have the normal kind of structure as a normal text generation LLM. It just generates the relevancy scores with the documents. Yes?
It's similar, the technique is similar to, for example, dynamic ranking technique that, I don't know if Algolia Search is using right now. I'm not sure if you're familiar with this kind of solution.
I wouldn't know.
Yeah,
But there are some open source options for this. I think Colbert is one of one of the models that does this, and you can also use an open source, a trained kind of fine-tuned model to do this. You don't have to use their API. I just think that their API is fast because they are running the GPUs for me, which is cheap. Okay, so you have the extra documents, you filter out, and you get great results. And this is much better than, for example, just doing relevancy scores, because you can actually get it's better than doing similarity search or vector search, because you can actually get only the top documents as an input to your LLM, so less distractors. Another one is multi-document agent. So someone talked about using agents. This is a very interesting approach that Llama Index, I guess, is doing. And of course, you can also implement this on your own. But here's one way I would think about this. You have your input query from the user, you rewrite it, and for each query, you have a specialized agent that is going to take that query. Example. Actually, this is an example from Llama Index. You have a document, for example, Uber's returns or investment portfolio, whatever. You have an LLM or a function call that is specialized to catch only that query. Uber information, you use this agent, and that agent has a particular namespace or a separate vector database that it can retrieve information from, and then you combine the information from different agents. At the end, you get these documents and you create the answer. That's one way. Another way would be to have each agent answer the question and then have a summarizer at the end, another LLM that just summarizes all the responses from each agent. The problem with this is that it's expensive. You are running an LLM here, you're running an LLM here, and you're running an LLM here. So you're pretty much you're paying 3 times the amount of tokens just to generate the response. It's good, it works. If you have the funding and the money, go for it. Oh, so any questions here? Any questions? Sure?
Do you rewrite the queries with the context from a previous conversation, or
Yes.
do you just rewrite the query basically just with the context of that query?
I'll be spilling some beans on secrets I use. So basically, what I personally do, if there is a history, if it's not the first question the user asks, I rewrite it. If there's any history, I rewrite it. If it's the first question, no need to rewrite because you don't have any context. You can still rewrite it to potentially improve it, but sometimes because of the lack of context, the LLM might infer something that's wrong. So if you're rewriting all the queries, the user might be asking something and not getting that because you are rewriting the first query. But if it's the second query, you can rewrite it. Yes, please.
Do you cache the answers for the rewritten queries?
Do I?
Do you cache the answers, not to query again if the question from another user is the same?
No, I don't use I don't kind of use cross history across users because each user has their own private data. I wouldn't want to find queries that are common across them and use and kind of cache those because you don't know. Since the answer has a context that's relevant to the user or documents from the user, you are pretty much exposing information. So that's not good. But if you're running an application that doesn't have those privacy concerns, it's okay to cache similar queries. Hopefully I answer your question. So now, this is the one thing that actually blew my mind. It's called the parent document retrieval. LangChain has this implementation. How I came across this is a very interesting use case. So I talked about the question that I had that was in the middle of the page. And since I embed the entire page, when I do retrieval, it wasn't working. So parent document retrieval fixes that. Yes, if you do hybrid search, you might get it, but parent document retrieval helps because you create chunks. For example, we have a page, I will show this. So basically, you have an input, and each input returns certain chunks, right? Certain documents, and each document is matched to the parent that it comes from. For example, you can imagine that this is a section within a page. So since we caught section 1 and section 2 from page 1, we return the entire page. So now, because you kind of can infer that the question that the user is asking is within that page, right? So if you return the entire page and you have a powerful model like GPT-4, for example, it will be able to find the answer better than if you are just returning that chunk, because that chunk could be the most similar to the query, but doesn't contain the full answer, right? And how this works, actually I made this and I tweeted about it and posted on LinkedIn. It's a very interesting mechanism that I think people should know. So we start here with the full page or document retrieval. Basically, you have this page, and this is actually the page that was giving me a lot of trouble. The context I want is here, is in the middle. But relevancy search, how do you call it? Vector search only gets, for example, the top or some of the bottom. It has a hard time catching here in the middle. So what you do, you create chunks, and each of one of these child chunks is kind of referring to the parent chunk, which is the entire page. But you might have a different use case where you don't want to return the full page. And one thing that you can do is that you can create chunks, and those chunks have smaller chunks, right? And whenever you kind of get the small chunks, you return this particular section instead of returning the entire page. So these are two ways of doing this. And on step 2, basically, you're doing just similarity search. You get different documents, different chunks, and each one of those chunks is kind of referenced back to their parent, and we return those parents as the context. Any questions?
I have a question, please. Because
Sure.
I have a question how you embed this. So only parent, only child, only grandchild, or everything?
You can embed both parent and child, right? So that if you want to kind of include the parents in the context, but LangChain does this in a very interesting way. It kind of just IDs the parent. You kind of create chunks of the childs, right? Or this child, you create embeddings of these childs, and this child's already referenced back to the page. So that's one way you can do it. You save money. You're not doing double embeddings, but there's another function that it calls multi-query, not multi-query, multi-vector embedding, something like that, where you are creating two sets of embeddings for the same document, right? That way it might help you catch more things, and since embedding is very cheap, you're fine. But personally, I think for my use case, I actually tested just this instance here of the full page already solves the problem. And that was the only problem I kind of noticed, yes.
How do you time them so nicely?
Come again?
How do you time
How do I?
text? How do you time this text so nicely?
Oh, so we will talk about chunking, but basically there's a lot of ways of doing chunking. Most people just chunk based on new spaces or a particular kind of structure of the document. And I prefer the kind of semantic structure of the document. So in this case, this document is properly sectioned because you're not creating a chunk here. You're creating a chunk of the entire kind of section, which is better if you're doing retrieval augmented generation.
What if the text is not formatted?
Oh, well, I thought about an idea for that, and my idea was try to find a way to convert it to Markdown or have an LLM rewrite it to Markdown. It's expensive, but that was my idea. Like rewrite it to Markdown and then use a Markdown splitter. And if you can have your documents in Markdown, better. I think in the future we will have better kind of better ways of doing this. They are cheaper, but at the moment that's what I thought about. Perhaps there's a better idea out there. I would be happy to hear. Yes.
So, do you have like only one level, Jeff, or there might be more levels?
Yeah, there might be more levels. These are the two levels that I saw that they implemented, but I think you can create your own and kind of go create deeper levels.
How would you determine whether that you should start or go deeper to create more levels?
I think that is basically through experimentation. That's why machine learning is beautiful. You experiment until it works. Like 0.75 is very arbitrary, but it took a lot of experimentation.
Okay, I see what I continue.
Okay, but you can ask your question.
No, I just wanted to say that we were trying to do something like I think what one of you asked. So trying to chunk by the context, right? So we and I found some article when there was a guy who proposed some algorithm where you calculate embedding for every single sentence, and then you like iterate over the sentences, and you calculate the distance between.
Yeah,
them
that's
to find
also.
out the like a context change. Right?
Exactly, and then you can fuse the embeddings of those different sentences.
It works well. Really, you can have this paragraph.
Absolutely, that's a good idea. I'll think about it and see if I can implement it. So you have document processing. That's kind of the first thing you're doing when you're creating your RAG. And there are three things that I think you should think about. There is more, but there are three top things that I think you should think about. First is beware of your splitting strategy as we were speaking. If you just naively split your documents, you're gonna get really bad chunks, and when you run retrieval on those, it's not gonna work. Because the particular chunk you retrieved, it's probably similar semantically, but it's not really the full answer. Second is like the chunk size matters. If you create really big chunks like I did, you'll have problems. You won't be able to retrieve, and we already talked about this. And the final one is handling edge cases gracefully. So PDFs, for example, are not exclusive text. Some of them come with tables, graphs, and so on, and all of those tables and images, you can kind of classify them as the top edge cases. And I think here to solve this, you should have conditions where you're checking for images in your documents or checking for tables and finding ways to embed those. Or creating completely separate pipeline where if you identify any of these items in your document, you create a kind of a pipeline, or you tell the user, you inform the user that we are not going to process table X, Y, and Z, or the image X. Next, we have prompt engineering. We had a great talk about prompt engineering, but here are some of the top things that I learned. First, models behave differently. So in Kulissiwa, we have GPT-3, GPT-4, GPT 3.5 Turbo, GPT-4, Gemini Pro, and Mistral Medium. And the same prompt that worked well with the GPT families of models, it did not work whatsoever with Gemini Pro and Mistral. They were failing miserably. So I iterated on it and found the common prompt that worked. But it doesn't mean it's the best prompt in the world. It just works for my use case. Then you have explicit instructions. So it's better to say use bullet points, return JSON only, than, yeah, I want you to format the answer nicely, right? So be more explicit in your instructions. Another one is, if you can, use few shot. So give an example of what you want it to look like or the answer to look like to the model, and these models are pretty good at understanding and picking up those ideas. Even if it's just one example, two examples, test out and see how many examples it takes to teach the model a new behavior. Then finally, it's like emphasize, re-emphasize if you can. In my prompt, for example, I have a part where I explain the model what to do, and then at the end I say, remember to do the same thing. I know it's a bit repetitive, but because of that remember tag, the model can kind of understand. And I found out that having the instruction at the top and towards the bottom, it kind of helps the model behave better in my use case. Then you have retrieval. If you can go SaaS, it's pretty much free infrastructure management. They are gonna manage all of your infrastructure. For example, I use Supabase. That's where I store all my embeddings and my documents. It's easier. I don't have to create my own instance and manage that instance and scale it. It's easier if I just use that. But if your company has enough money to burn, go ahead and go on-prem. Then you have latency. Ensure the latencies, the responses are as fast as possible for the use case. If it's batch and is set to be delivered at 9 a.m., it should be delivered at 9 a.m. If you're creating a chat interface that the user needs to get the response immediately, try to see if you can implement streaming, for example. And then scalability. So make sure that your pipeline, your entire RAG pipeline can scale. So let's say if you increase the number of queries that that your vector database is getting at a particular second, how will it behave? If you use bigger embeddings of, let's say, 2,000 dimensions, how will it behave? And here are some of the examples of this. So Supabase released this article where they talk about serving 1 million embeddings of 1,536 dimensions. That's just pretty much 1,536 numbers, and each using of the 1 million embeddings using Postgres PG vector extension. And you can see here that they are better than Pinecone. They can serve 780 queries per second at 99% accuracy compared to Pinecone. And a clear example of this is where I think if some of you, if attended my previous talks, you can see that I was actually benchmarking these technologies, and initially I was using Model Labs with Pinecone, then I switched to Vercel and Supabase, but it turns out that Vercel and Supabase it actually took longer, it took 12 seconds to respond, because out of these 12 seconds, 6 seconds it was taking to retrieve my documents from the vector database. And I was like, that's odd. Why is it taking 6 seconds? I'm indexing my database with HSNW, which is a technology to kind of make things faster. And I kind of switched to Cloudflare to test it out, and I got my overall response latency to 3 seconds. That's incredibly fast. It's faster than you can even type. So I got these results by migrating from Pinecone to Supabase, Model Labs to Cloudflare, because Model Labs, the problem was that it took 2 seconds, 1 second to 2 seconds to start up the container. And Cloudflare, since its edge functions is JavaScript runtime, it pretty much starts instantly. There's no wait for startup times. And I got my accuracy to 99% and under 5-second latency. So now, finally, monitoring. Here we have, there are a couple things that you should think about when you're doing monitoring. First one is 4 golden signals. This is, I think, an article that Google published. These are the kind of metrics that you should be looking at: your latency, your traffic, errors, and saturation. You measure these, you're up to a good start. Then you have user feedback. Thumbs up, thumbs down. But it turns out if you include this in your application, most users won't do it. The users that will do this either love your product or are very good people. Not that everyone else is not, but it just takes a different kind of person to do thumbs up, thumbs down. Then you have performance for each step. Be able to continuously monitor and track how your pipeline is performing at each step, right, of the generation. Then you have app usage. How are people using your application? What type of queries are they asking? Are people coming to ask questions that are just out of context with their documents? Is that kind of an education problem? What is wrong with the way things are going? You kind of should monitor these. Personally, at the moment, I'm using Mixpanel. I just deployed it last week, and it's been amazing. I've been seeing people ask, like, generate JavaScript code, and I just understood that, oh, this person is not well educated with the application. Either I have to improve onboarding, or I have to kind of be able to show better the application flow so that the user can understand what to do. So you'll be able to see this information by doing that.
Can you repeat the name? Sorry.
Mixpanel. So here we have Langsmith. Here you have Langsmith traces. It's great for understanding how your application does step by step. Here you have, for example, here's how long my application takes to get the vectors. It's around 2 seconds, but then most of the time was spent on retrieving information for Mistral. Like Mistral takes a long time to generate answers, for example. But the application overall is pretty fast at running. So you could try Langsmith for this. It gives you all the information about your application. In terms of evaluation, there's a very simple idea. 3 things you could do: either evaluate manually, use an LLM, or use both at the same time with human in the loop evaluation. You can go to this repo here. You'll find all the code, and I'll upload this in a couple of days. Right now, I'm fine-tuning Phi 2, a model there, so all the information that you need around LLM ops you'll find there, and I'll include RAG in a few weeks. And finally, there is Kulissiwa. Here's Kulissiwa answering a simple question: what is Tesla's income for 2022? It answered correctly and also attributed the sources, so you can see the source number 1 is the one that used here, and I built this on my own. 4 things to think about. Finally, infrastructure management. Be able to, if you are using SaaS, it's better. You don't have to think about scaling and latency. You can put that load on the infrastructure company. Then modularity is key. Any parts that you saw in the pipelines I demonstrated today could be swapped out, or you could create your own hybrid infrastructure or your hybrid pipeline. Finally, iterative deployment. Make sure that you are continuously improving your application, and if you have the data, fine-tune it. I had this one more thing. So Kulissiwa right now is loved by 100+ people from top companies like NVIDIA, Neptune AI, and so on. And this is a graph of our active monthly users from last December. And we are currently raising funding to build Kulissiwa Smart Onboarding, which is a application to help SaaS companies create better custom onboarding flows for their users. Onboarding is a very hard problem, and a lot of companies have been reaching out, and we are now raising because, yeah, the infrastructure to build this is massive. It's not only LLMs, it's way beyond that. And here's the Loom video. I will share the slides, and you can check the Loom video through the slides. And that's a wrap. Thank you.